Okay, I believe it's recording.
Alright, let's do this then. So, I'm going to prove to you what the last digit of pi is. I will show it. And we're going to begin with this little piece of math, the Bailey-Borwein
Oh god,
formula.
this.
I don't care if I'm pronouncing it wrong, right? So, as you can see, this is the formula. Yes. It gives rise to a special algorithm for computing the nth base 16 digit of pi. Correct. So, that's cool, right? And this does not compute the nth decimal in base 10. I don't care for that right now. But yes, basically we can at some point get a formula for indeed pi. Correct. So we have this, right? Yes, we do. So we have this formula here. Okay. So pi is equal to this, correct?
Equal to
And
that
then we have
formula.
this.
Yeah. If
Yeah.
n is
And then we have
infinity.
this. Yeah. Okay. So we're gonna have this digit extraction algorithm for pi. Yes? Okay. So this means that
I don't believe I can see your mouse if you're pointing at.
no, it's fine.
Okay.
So if we're looking here, correct,
Mm-hmm.
we are basically going to want to get those things. So we have what? We want to get this digit extraction algorithm for pi. So let's begin by rewriting this thing in Wolfram for now, because as I said, machine assisted proof, correct? So
Mm-hmm.
let's just 4 times sum k equal to 0 to inf. Actually, no, sum, what is the formula? I'm just going to copy this for my second monitor so that I can type it. So it's gonna look smart. Okay. Sum of this 4k equal to 0 to inf. And I'm going to in brackets. Okay. Plus 2 times. Oh, wait, it's minus. I'm sorry, I am not going to. So far, this is going to be very boring, but trust me, it will pick up steam later. It will be very spicy later. Okay, are you ready?
Oh, I thought that said 2 to the 0 minus 0 minus 0, and I was like, okay.
So true. So true. No, don't worry. Okay. And this is 4 times sum of 1 over 16 to the power of k times 8k plus 1. Yes. Okay. And then we're also going to want this sum to exist here. Yes. And that'll be 8k plus 4, 8k plus 5, 8k plus 7, I'm pretty sure. 8, 4, 5,
Don't
6.
tell
Sorry,
you've memorized this.
I haven't memorized this, don't worry. I
Oh,
have it open
okay.
on my second monitor.
Oh, okay. I was gonna. It looked like you just like weren't opening. I was like, are you that sad?
Can you imagine? Okay, so we're just gonna force Wolfram to do this as our math slave, basically. And as you can see, this
Yeah,
is
pi.
correct?
Yeah.
Okay, good. So we're going to want to obtain a specific digit, correct? So what Wikipedia says we should do, and as we know, Wikipedia is just always factually correct, and it's basically just
Yeah. It's infallible.
If it's said,
Yeah.
if it's said on Wikipedia, it has to be true. Proof. Have you ever seen a counter argument? I don't think you have.
Mm-hmm.
And if that doesn't work, then we're just going to give you proof by intimidation. So,
the fourth proof style intimidation.
intimidation, so true. Okay, so for a particular value of anything for some blah blah blah. So basically, we are going to go ahead and Yep. Okay, I see. So that's how it's gonna work. Okay, so what we're gonna have to do is basically modify this a bit. Oh boy.
I really
Just gonna
hope
save a second
OBS
notepad file.
records the video and audio. I should have checked.
Rip. It's fine. Okay,
It's
whatever.
fine.
So let me just rewrite this a little bit. So this is gonna be 4 times, and this is going to be a wacky little thing. So listen up. So I'm basically just going to follow what the Wikipedia says because, well, obviously it has to be correct, no?
Yeah.
Yes, that's the thing. Okay.
I don't
so
think
what we're gonna do
Wikipedia has
is-
ever been wrong about anything.
Exactly about anything ever. N. Then we're gonna have a plus bam, and this is all gonna be in a bigger thing here. And k equal n plus 1 to infinity? Yes, yes, yes. And this has to be 16 pow n minus k.
How are you gonna define the n?
N? Oh, n is just the digit we're taking, by the way. Don't worry about it. We can just set it something else later. And by the way, please ignore the fact that this formula doesn't work for the 0th and first digit. We can ignore that for now. It's fine, it's fine.
Oh no.
Anyway, trust me, this is really good mathematics. You'd not want.
Let's find the negative first digit.
Yes, I agree, I agree. We should find the negative first digit of pi. Mod 8k plus 1, and then this entire thing has to go into another. God, this is so sad. Whatever. And I'm gonna divide this by, of course, 8k plus 1. Yep. And this is just the first sum, because we have to add the second sum as well. This one's significantly simpler to write though, so don't worry about it. And this is going to be sum of 16 to the power of n minus k. Yep. And we divide this by 8k plus 1. Yep, okay. So now we just take this big goddamn beast and do a little trolling.
Oh,
I will
no.
rewrite the rest to be correct now. So then we have minus 2 times, the second one was 8k plus 4, so I'm just gonna switch the 1s to 4s, and I don't really care if this is how you should do it, but
This
it is how
is
I do it,
making
so
me
I think it'll be
uncomfortable.
correct.
This is making me uncomfortable.
Don't worry. Okay, anyway, so let me just try to get this all
I
done, but
really
think
don't
that
like the n minus k. That
is-
is.
I mean, no, don't worry about it. Do not worry about it. That should be fine.
Oh wait,
Wikipedia says
why are
fine.
why are you using modulus?
Because I'm getting the end of digit. Wikipedia says
Oh,
we should do it,
oh
so it's
god.
true. It's actually because mod 8k plus 1 gives us removing some whole numbers. We don't need them, basically. It's fine, it doesn't matter. Okay, so... No, it genuinely is fine, though, trust me. This is not yet as horrible as we're going to get. Trust me on this one,
Oh god.
okay? So, we go for 8k plus 6, 8k plus 6, yes, yes, yes. So, this is plus 5, this is plus 5.
If
plus
this all
5.
records right, I want to put it on YouTube
That's fine by me, yeah.
and
don't
call it
worry.
something stupid like when you
Proving-
when you're
Yeah, let's
retarded
do
and you
something.
like math.
The maximum number of characters. That
Rigorous
is so
proof.
sad.
No Wolfram moment.
Oh no, Wolfram moment, hold on. So I've exceeded the maximum, huh? That's fine by
Oh.
me. I'm just going to do the things separately then. So let's start with 4 times this sum, right? Let's remove everything else, just 4 times this. This is the first sum, we had 4 of them, so...
Oh god. Oh
Okay,
no,
this will take a
it's
while
not
to
a good
do.
sign when Wolfram takes this long.
Yes, I don't care. I'm just gonna say n equals 1 maybe. Or maybe just slum it into decimals, it's fine. No, it's not fine, it's not fine, it's not fine, but... actually, yeah, no. I'm just going to manually edit the n in this case, so this will be 16 times... Let's start with n equals, let's say, 3, sure. For k 0 to 3, and then this is 3 minus k for k equal to 4 to infinity. Yes, 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 okay. And maybe this will calculate, it probably will not, but it might. Oh, it actually did, perfect, so it's gonna be this. But this is the wrong thing, right? So
Wow,
we're
that
going
looks
to take
beautiful.
this- So don't worry, we're going to take that, right? We're gonna go ahead and take our result here. I'm just gonna save it in the notepad file because I do not want to think about this for too long. 5.71046. Approximations are always correct after all. So
Yeah.
next we're going to have to
Engineering.
calculate engineering. Correct.
Do you watch
After all,
Flammable Maths?
Yes, I do. After
Yeah.
all, listen, I is actually equal to e, and that also proves that that 3 squared is 10. I can show
Yeah.
that later. It's
Yeah.
fine. Actually, you probably know that already, fundamental theorem of engineering or something.
Yeah.
Okay, so we're doing 3 here, right? Yes, we are. So 0 to 3, and then k equal to, here it's 4 to infinity. Yep. This is 3. I think that's all the n's replaced. Perfect. So now we do this, right? And this gives us 2.34175. Okay. So we're gonna add a minus 2.34175. And then we have two more sums to calculate, and I'm just gonna remove this.
I just want to say the viewer
this is
retention rate on this is going to be great.
I know. This is why you have to like modify it. Just skip ahead. Just say this
Yeah,
is boring.
yeah,
Skip ahead, and then at the end it'll be, because trust me, it gets really spicy once you're done with the boring parts.
Oh, hell yeah.
Okay, so then we have this, and it's like minus 1.69048. There we
Wait,
go.
isn't
This
that-
is okay?
No,
Come again?
no.
No, trust me. I'm calculating these right now. I know it seems weird to be doing it like this, but
No, it's just for a second.
will-
I saw the 0.69 and I was like, natural log 2. Oh my god.
There's not two.
I got overexcited.
It's fine. And then it's one.
Why don't we just? We should just round it up. Just round it up to ln2.
Agree. Anyway, I now had all of these written up. So what you have to do is this, and bam, we have minus 0.03. Intriguing. So, extracting the wanted digit, we now have to remove the integer part and multiply by 16. Theoretically, I think.
And why?
Hold on. Extract the wanted digit. No, it's fine. Let me just try to multiply. No, it's not going to be. It's not going to be fine. But
Oh
it's
god,
fine.
this is
Whatever.
such a. This is approximation moment.
Anyway, with approximations, you can see that we have gotten sufficiently close to the correct digit, which is yes.
Which is -1.
Yes, agreed. Which is -1.
What
Agree,
is
agree.
the
Hold on.
correct digit?
Well, this would be the third digit after in the fraction in hexadecimal.
Oh god
Guess.
damn it.
No, it's fine. Listen. Okay, no, I'm just going to skip ahead to the juicy part. So this is where you can start it. Okay. So basically, what we're going to do is just ignore all good conscience we have. Okay. We're going to take the first formula, just the one for pi, right? So why should we even start with this 0 to infinity bullshit when clearly we can just get pi?
If there are any children in the audience, cover your eyes.
and here.
Things are things are about to get dirty.
Just turn everything off. This is where it happens. So, if k is from 0 to infinity and that gives us the whole of pi, then clearly, just taking the limit as k goes to infinity, then clearly just starting k at infinity should be perfect, right? I mean,
Oh
I
my
can see
god,
what's
stop
there.
that right now.
Okay, so basically...
And then
what
we
we're
do
going
a
to
second
is-
one that's from infinity to aleph null. That should be
Correct.
fine. That should
And that, so basically, we can remove all of the sums here, and then we're just going. So we're gonna remove all the pointless sum stuff, basically, because we don't care about summing k from something to infinity. We are doing far more trolling here. Basically, we're just gonna take this, and we're going to assume that this is correct for a digit of pi, because I said so, and that is enough for me. Put this into brackets, and then find the limit as k approaches infinity of this. And we will get, surprise, surprise, 0. And therefore, as you can see, the last digit of pi is actually 0. Now, you may be thinking to yourself, several questions.
that's true technically. Technically,
That is, I mean,
that actually
the
somewhat
last digit
technically
of
makes
the-
sense.
It's the last digit of the decimal expansion of pi, and that is 0 in the fraction part.
Because if you think
So-
about it, if there ever was an end, you could just keep going with zeros.
So true. No, okay.
That's
but
so
I'm not done
wrong.
yet.
Oh,
I'm
no.
not even done yet. No. So we know that
Oh.
pi is infinite technically, but no. It's fine because
Oh no, I see. Oh, I see what you're. Now it just all came together. I was just like trusting
Yeah,
you all
so-
along, but now I see. Oh, that's disgusting.
yeah. So what else? What else? Oh, okay. Listen. Let's keep going. So, and as you can see, yes, this is the last digit of pi because we got k to infinity. So you may be thinking to yourself a few questions. First of all, this formula works for base 16. So what is it in base 10? Well, 0 in base 16 is also 0 in base 10. So I really have no clue why that would even be a question. So,
Yeah.
then you may consider asking, how can 0 be the last digit of a decimal expansion, right? Like, in its most reduced
Of a
form,
transcendental number.
Yeah, especially transcendental. Like, what number's decimal expansion ends in 0? And to that I answered 10, you dumbass. So, yes. And then, okay,
So pi
let's
equals
answer
10.
this point. But then I will answer this, okay? You may be thinking, doesn't pi actually have infinite decimals, right? Isn't it transcendental? Doesn't it have an infinite decimal
That's
expansion?
what they want you to think.
No, listen, it does, but that's in base 10, right? If we had, say, base pi, then pi doesn't have any decimals, so who knows? Who can tell how big
Oh
your
my
base
god! Holy shit!
Exactly, there you go, right? And you may be wondering if I am sure that this is the correct way to use this formula, and I am sure that I am using it in the way I see correct. Okay?
Are you done making a mockery of this?
Yeah, it's fine, it's fine. I'm done with this one, but there's plenty more I could probably try to do. But let me think if there's anything else I have that's like just truly elegant and incredible, basically. Oh wait, no, I have an amazing proof. Okay, here's some other just. Let me just post this in like. Do I post this in your DMs or in voice text? Because I have some other amazing proofs to show you. Okay.
Okay.